I want you to look at your green sheet. I want you to look at the second row on your green sheet. There should be 4 equations in a row there. We call these the kinematics equations. In fact, these are the big 4 for this unit and for next year. What I'm going to be doing for the next while is I'm going to derive the equations with you, because I don't like just giving you new information and Lena saying, wink, wink, trust me, it's right. I will try, because I'm a nerd, to prove things with you. I am not going to ask you to rederive these on a test, so don't freak out if you're going, Mr. Duick, there's no way I would have come up with that. That I'm not going to test you on. But what we're going to try and do is see if we can get these 4 equations. We kind of snuck one in already yesterday, because yesterday we talked about acceleration. We said that acceleration was the velocity change per second. We said that acceleration was the change in velocity over change in time. These are all vectors. I'm going to put the vector symbols in at the very end, not while I'm doing my work, because those arrows just clutter things up like crazy. So technically, there should be a vector symbol and a vector symbol. I'll get there, Danica. Who remembers, what does change in anything mean? It's also the, I think, first thing on your green sheet. Good. So we rewrote this as A equals V final minus V initial. And then I think I told you something dumb like, yeah, time is always a changing and we get lazy and sloppy and we just write a T and everyone understands it's a changing because we're lazy. Then we rewrote this one. We got the VF by itself yesterday during the lesson. When we did that, we got VF equals VI plus AT, which I think is the first equation in that second row. Double check me, yes? On your green sheet? So now in the box, I'll write it with proper vector symbols. So first of all, speed, final, equals initial speed plus acceleration times time, or velocity final equals velocity initial plus AT. Typically, we'll read this as VF equals VI plus AT. How many variables does that contain? 4. VI, VF, A, and T. So technically, how many equations does it contain? 4. What I'm going to start to teach you today, and it's going to seem a little weird at first, but I encourage you to buy into it, is how to glance at that and rearrange it in your head to get any equation that you want. I'm going to discourage you from memorizing the other 3 equations or writing them down somewhere. I'm going to say, trust me, it's a better place to get to. A little trickier, but it's a much better place to get to. It cuts down on your memorization tremendously if you can learn to rearrange these. We're going to do that. So first of all, we have VF equals VI plus AT. Let's put that in our back pocket and come back to it. That comes out of our definition of acceleration. We also talked about average velocity. Average velocity is displacement over time. I'd like to get the D by itself. How would I get the D by itself? What's the T doing to the D? So, okay, I can rewrite this. Displacement is V average, average velocity, times time. In fact, that's what we did for the distracted driving activity. When you started to do your calculations, you went D equals VT. The only reason I didn't put V average is you were going at a constant velocity. So I can write this. Did I give you that one on your green sheet? I can't remember. If I did, it would be in the first line, I think, somewhere. Did I? Yeah. It's redundant. I almost thought about not giving it to you because there's a better one with a bit more detail. But we have to talk about what we mean by average. Let's suppose Keegan has $10 and Brandon has $20. Between them, what do they average? How do you get a 15 from a 10 and a 20? What are you doing mathematically? Yep. Dividing by 2. Yes? So how do I find an average of two things? Add them together and divide by 2. How do I find an average of two things? Add them together and divide by, everybody, 2. So over here, let's make a little note. If you want to find the average velocity, divide by 2. What are we adding together? VI and VF. Divide by 2. I'm going to combine these two equations, Ashley. I'm going to take this and stick it where that V average is. You don't need to write those arrows or anything like that. When I do that, it's going to look like this. The D is going to drop down like a domino. The T is still going to stay there, but in brackets, I'm going to have VI plus VF over 2. Now let me write this a bit neater. It's going to look like this. Bracket VI plus VF all over 2 times T. That's average velocity times time in disguise. Is that okay, Raj? Hey, is that on your formula sheet? I think in that row of 4, that's the second one, which is why I said that one above it that says D equals VAV times T. It's redundant, really, this. How many variables does this have? 4. How many equations does it technically contain? Everybody? 4. Do you want to memorize the other? No. I'll teach you how to derive the other 3. I should point out this assumes uniform or unchanging acceleration. What I said to you yesterday was in physics 11, I'll let you step on the gas or I'll let you hit the brakes. But once you've done that, I won't let you push harder or ease up. So we can't change our acceleration. Once we start accelerating or decelerating, we're stuck with it. If you have a changing acceleration, it gets a little ugly. You need calculus. So if we have uniform acceleration, we can find average speed by, add them up and divide by 2. VI plus VF over 2. Oh, by the way, sorry, in this box, you can also put a vector sign over VI and a vector sign over VF now. That's the vector version of that equation up there. And what that means is if you're going backwards, make it negative. If you're going forwards, make it positive. If you're going down, make it negative. If you're going up, make it, pay attention to your directions. Okay. So we have average velocity, is that there? Or average speed, is that there? And then, now I'm going to turn the page. We're going to start out with this equation, the second one that we just got. D equals bracket VI plus VF over 2 times T. But now, Eric, I'm going to combine that equation with the first one, VF equals VI plus AT. Nick, can you read this to me again? VF equals what? VI, right from your green sheet. Say it again, you're right. VF equals what? Not making fun of you, I'm making a point. Say it one more time. What does VF equal? So what can I replace VF with? Say the same thing. Say the same thing. So this VF right here, look up. You know what I'm going to replace it with? A VI plus AT. That's my next step. It's going to look like this. The first VI drops down, but the second VF becomes, yes, Nick, you're correct, a VI plus AT all over 2 times T. This next part I will not ask you to recreate on a test. This is me showing you where the equations come from. What's 1x plus 1x? What's 1y plus 1y? What's 1vi plus 1vi? Okay, I can rewrite this as D equals, in brackets, 2 vi's plus AT all over 2 times T. By the way, if you're wondering where we're heading, we're trying to get to the third equation in that list of 4. So see if you can spot how we're going to get there. First thing I would do now, see this t outside of the bracket? Kate, I'm going to multiply it in the bracket. Dunk, dunk. Distribution or front door bomber if you had Mr. Rock. I've never understood that one, but I'm going to multiply it in. I'll get this. D equals 2 VIT plus A, look up everybody. What's a better way to write T times T? I'm going to write AT squared all over 2. Is it looking a little bit like that third equation? A tiny bit, a little bit, kind of? Okay. Now, Jan, is this whole fraction all over 2? Say yes. So is this first term being divided by 2? Say yes. And the second term is being divided by 2? Say yes. So what I'm allowed to do is actually split this fraction up. I can break this up into 2 VIT over 2 plus AT squared over 2. I'm allowed to do that. Now, why did I do that? In that first fraction, Jan, is there a 2 in the top of the fraction in the numerator? Is there a 2 in the bottom of the fraction in the denominator? You know what? That's 2 divided by 2. They cancel. And so here's what I get. When I combine the first equation with the second equation on your formula sheet, I get a third equation that looks like this. D equals VIT plus a half AT squared. Where'd the 1/2 come from? We're dividing by 2. That's the same as timesing by a half. And now I can bring in the vector symbols. So displacement is initial velocity times time plus a half times the acceleration times t squared. I see some of you at the back going, can't read that. This here is probably the most useful equation because it combines 2. It's also the toughest one to work with. Who are my grade 12s here? Because it's a quadratic. The grade 11s don't know what that is yet, but see the squared? Spoiler alert. It's a quadratic. Oh, how many variables does this equation have? 1, 2, 3, 4. How many equations does it technically contain? Everybody? We're up to 12 right now. I had somebody last class say, well, Mr. Dewick, can't I just, we're going to do one more that also has 4 for a total of 16 equations. Couldn't I just write all 16 equations on my formula? No, because if you do that for the next unit and the next unit, you're going to have about 180 equations on your green sheet. You won't be able to find anything. Don't. And besides, I'll teach you how to derive them in your head, Zach. And it's a kind of a nerdy, good place to get to. Also, those of you that are taking or in chem, it'll help you in chem, it'll help you in math. There's a fourth equation. Y'all see the fourth one in that row, the one with the squared? I'll derive that one with you next year because I can see that I'm losing you. The fourth equation is VF squared equals VI squared plus 2AD. Can you all make sure you know where that row of 4 is on your green sheet? Y'all see it? Anybody doesn't have their green sheet handy? Like, I'll get them one if they can't find it. Okay? So these are the 4 uniform acceleration equations. Sometimes they're written a tiny bit differently, Brea, especially in Britain. Instead of using initial and final, instead of using initial, they'll use 0 because they'll say, well, at time 0, that must have been your initial. Although in Britain, they won't say 0. Do you know what they call that in Britain? They don't call it a 0. What do they call it? They call it a naught. And so because I had a British high school physics teacher who was my nerd hero, as a matter of fact, he won the same award that I did. I was very proud when I won my Prime Minister's Award because he had won one and I was like, passing the torch. You might hear me occasionally say V naught, and I might even say it with a British accent because I'm probably channeling my Mr. Cowell, my high school physics teacher. These are our 4 kinematics equations. VF equals VI plus AT. D equals bracket VI plus VF over 2 times t. D equals VIT plus a half AT squared. And VF squared equals VI squared plus 2AD. No, no, no. Not, we're getting to the good stuff now. Should be, can't believe that. We're going to do some examples. Monday, we're going to do word problems, physics, actual applications. In fact, Monday's lesson is called Applications of Acceleration. I'll show where you can use it in RCMP crash scene investigation and designing stops, all sorts of stuff. But today, I'm just going to give you the data. I use an approach that I call DFIC. It's an acronym. The D stands for list your data. The F stands for find the formula. The I stands for, hey, now insert the numbers. And the C stands for crunch the answer, calculate the answer. That is not an end-all, be-all, but if you're looking for kind of a hook to hang your hat on, Lena, if you're stuck, in fact, if you ask me a question, Mr. Duick, how did number 7? My first question to you will probably be, did you DFIC? If you haven't, do that first. List your data. Okay. The other acronym, you don't need to write this one down, we'll do it in the notes later, that we use all the time is DALP. And DALP stands for draw a little picture. So what you'll hear me say as we really get into this course, when in doubt, you don't know what to do? DFIC and DALP, then call me. I've done the listing the data portion already. This is what I would have pulled out of the question. So I've done step 1 already. What has a Marcus, what has a question mark next to it in example 1? What are they asking me to find? Okay. If this was a word problem, Marcus, if this was a word problem, Marcus, it would have read something like this. A car starts out going at 3.2 meters per second. It accelerates at 2.9 meters per second squared for a final speed of 29.6 seconds. How long did that take? That would be the actual word problem. We'll get there. First of all, what's it asking me to find? You said it. What else did they give me? VF? Yes. VI? And A. Marcus, out of those 4 equations, there is only one equation that has a VF, a VI, an A, and a T in it. Find it and tell me which one it is. And all of you on your green sheet, find from those 4, there is only one equation. And that's the skill we're going to start to develop today and next classes. Can I even figure out where to go? Have you got which equation, Marcus? Okay, look at your green sheet. Are you still writing stuff down? Look at your green sheet. You're not looking at your green sheet. Okay, Sesame Street's brought to you by the color green. See the row of 4, the second row down? See them all? Okay, only one of those has VF, VI, A, and T. Those of you that spotted it, keep it to yourself. This is the painful skill we kind of got to get through, but we'll get there. Which one? Read it. You're right. Everybody write that down. I will usually make these questions worth 2 marks, and I will give you 1 mark just for finding the equation, because I think that's the most important thing. Now, what are we trying to find, Marcus? We're going to get the T by itself. Just so you can see what I'm staring at, I'm going to put a little red dot above it, just so that's what I'm looking at. What side of the equation is it on? Left side is going to drop down like a domino. The VF drops down. What's right next to the T, Marcus, my friend? What's the A doing to the T? How would I move it to the other side? Yep, remember that, remember that. We're going to divide by A. Don't do it yet, but remember that. What else is on the same side as the T? What's the VI doing to the T? How will we move the VI over? Can you see how there's kind of, I call them breadcrumbs, like from Hansel and Gretel. There's kind of breadcrumb hints as to what we're going to do. It's the opposite. So I'm going to minus a VI. I'm going to divide by an A. The question is, what's the correct order? And the answer is reverse BEDMAS. We're going to do our adding and subtracting first. So what are we adding or subtracting? We're minusing what? There's going to be a minus VI. And then what? All divided by A. Look up, don't write this next bit down. Everybody look up. That equals T, but do you mind? Can I put the T equals on this side? Because that's where we're used to seeing the thing by itself, T equals. So I'll do that as my last step in my head. That's another equation. Are you going to memorize it, Ashley? No, I'm going to teach you how to derive all these. Don't try and add all these to your formula sheet. By the end of the course, it'll look like your pencil puked all over the page and you won't be able to see a thing. Okay? Marcus, what's VF? What's the final velocity? The question told me. Good. Minus, what's VI? All over. What's A? Everybody get your calculator out. Marcus, is this a fraction? Is there more than one thing on the top? So if you have the fancy schmancy fraction button, you'll hit that, but the rest of us, we've got to open up a bracket. And then 29.6 take away 3.2. Have we reached the end of the top? Close off the top. Fraction means which mathematical operation? Okay, so divided by. Is there more than one thing on the bottom? So do I need brackets around the bottom? No. If there was, I would. Do you all get 9.1034? That? And we said final answers, let's just go to 3 sig figs, so 9.10. And the last step, Marcus, you don't want to go work for Verizon. What did we just find? Units. This is why it's worth memorizing what units go with what. So your final step, seconds. I often draw a box around my final answer. That's like spiking the football after a touchdown. It's just a habit. You don't have to. This is what we're going to reach the point where, in fact, my goal is most of you go from this line here to this step, skipping the middle step. If you can do that in your head, I'm good with that. In fact, I encourage you to do that. Next page. Lena, what has a question mark next to it in example 2? Yep. D. So we're looking for an equation. It has to have a D in it. And it looks like they gave me a VI and A and a T. Of those 4 equations, folks, there's only one that has a D, a VI, and A, and a T. Can you find it? If you find it, great. I'll wait for a second. Can you find it, Lena? Okay. Now, there's a good trick that you can use. There's actually 5 variables in total. Look up. There's VI, VF, A, D, and T. If you know any 3, you can find the 4th one, which really means if you know any 3, you can find all 5. Lena, I notice there's no VF given to us. So the other way you can do this is you can read me the only equation that doesn't have a VF. Does the first one have a VF? Does the first one say VF equals? Has the VF in it? Skip it. The second one with brackets, does that have a VF in the equation? Skip it. The third one, does that one have a VF in the equation? Okay, I'm looking at that already. Now let's do the check. Does it have a D, a VI, an A, and a T? That one. That's how we're going to get good at this. In fact, probably by the end of next week, your brain will do this subconsciously without you even thinking about it. The same way you might remember in Science 9 or Science 10, when you were doing the periodic table units, you might have thought of an element and your eye might have stared at the right area on the periodic table, even though you didn't remember that that's where it was. Your brain just kind of, yeah, it's over there somewhere. What was the equation? Can you read it to me, Lena? Good. If this was a word problem, it would have said something like this. A car starts out going backwards at 1.5 meters per second. Why did I say backwards? Negative. It accelerates forwards at 4.5 meters per second squared for 12 seconds. How far does it travel? That's what this is asking. Okay. What am I asking me to find? What letter? I need to get the D by... Oh, already is. That'll happen sometimes. So now it's just going to be straight plug and chug. D equals, Lena, what was VI? Yep. And then T was 12? Plus, what's an easy way to write almost gave away the punchline. What's an easy way to write 1/2 on our calculator? Everybody? Okay, so I'm going to now go 0.5 here. A, 4.5, and 12. Most common mistake, kids forget the squared because they're so relieved that they've gotten to the end, they relax. We're going to type this, all of us, together on our calculator because I want to show you how you can type this with the fewest number of keystrokes and the maximum organization. So don't type yet. Okay? Lena, when I handwrite, using brackets makes it easy to show multiplication, but on my calculator, brackets get confusing. So I'm going to go like this. Everybody, let's all type negative 1.5, no bracket. Instead of a bracket, what am I going to hit? Times. Yes? What's the next number, Lena? 12? I'm not going to hit equals. I'm going to type this all in one line because you've listened to me. You've gotten a good calculator. You should be able to do this all in one line. So 12 plus 0.5 times, not a bracket, 4.5 times, not a bracket, 12, and then you all need to find your x squared button. If you can't find your x squared button, this is your chance to ask. If you find your x squared button, all of you should get 306. And if you've listened to me and you got a good calculator, you probably were able to see almost the whole line in front of you and proofread it as you were typing. Yes? That's one of the reasons I really wanted you to get a good calculator. Okay? Is it 306? Yes? If you didn't get 306, raise your hand and I'll come help you. Good. Lena, what did we find? What does the D actually stands for? D-I-S-T, units. Yes. Always do your unit check before you sign off. Right? Okay, you can relax now. Sorry, I do call on people as we go, but also, by the way, if I see you yawn really big, you're up next, so just stay awake. Right? Right. Ooh, example 3. Kate, what are they asking me to find here? I'm looking for an equation that has a VI, an A, a T, and a D in it. There is one and only one. Which one? Can you read it to me? Plus a half A, T. So the same one that we just did, except what are we trying to find? I'll put a little dot there. This is a tough one. By the way, if this was a word problem, it would say something like this. A car is accelerating backwards at 3.5 meters per second squared. Why did I say accelerating backwards? Okay. Or I could have said slowing down. For 24 seconds, it ends up 40 meters behind from where it started. Why did I say 40 meters behind from where it started? Negative 40, okay? So that's where the vector language is going to come in. You have to pay attention to direction. What am I trying to get by itself? Okay. What side is the VI on? What's going to drop down like a domino? The left side, the D. What's right next to the VI? How will I move that T over? Remember that, remember that, remember that. What else is on the same side as the VI? A 0.5 AT squared. That's all one thing because it's all clumped together. What else is on the same side? A 0.5 or a half AT squared. What's the half AT squared doing to the VI? How will I move the half AT squared over? Do you hear it? Minus. What order? Reverse bedmass. So talk me through it, Kate. Minus what? 0.5 or 1 over 2 AT squared. And then that whole mess by not by VI, by T. That would equal VI. Do you mind? I'm going to put the VI equals on this side because that's where we're used to seeing the thing by itself. That is yet another equation. Will you memorize it? Everybody say no. I'll teach you how to derive this. Now, this step is going to click at different rates for different people. As long as you don't quit on me, it will click. It will. If you quit on me and I'm just going to write all these out on my formula sheet, well, I can't help you. So don't be that person. Is this a fraction? Okay, let's write out the numbers. What was D? And then a minus sign and a 0.5. and I'll write brackets when I handwrite. So negative 3.5, 24, don't forget the squared, all over 24. So is this a fraction? Do you have the fancy schmancy fraction button? So you and I are going to open up a bracket. The rest of you are going to hit your fancy schmancy fraction button. Negative 40. Take away 0.5 times negative 3.5 times 24 squared button. Now what? Close off the top. Divided by, do I need to open up a bracket? Okay. And I got 40.33333, 40.3. Yeah. Units, it's a velocity. Meters per second. Ooh. This one's got some teeth. Mud, which equation? And what Mud's doing right now is he looked at the first equation and he said, oh, that's got a t in it and I don't have t. So he moved to the next equation. He said, got that. Oh, that's got a t in it. I don't have t. So probably your eye has moved to the third equation and you went, I got a D, I got a V. Oh, that one also has a T in it. I don't know T. So now you move to the fourth equation. You said VF check, VI check, A check. Ah, it's a squared one. Okay, that's the process of elimination that you're going to do, but you're going to get really fast at it. Read it to me, Mud.
Final squared.
VF squared equals
VI squared
plus. Yep. What are we trying to get by itself? Oh, it is. Or is it? Oh, it's squared. What's the opposite of squaring something? Holy smokes, Mr. Dewick, square root's actually going to be useful? Oh, yes. So here's what I'm going to write. I want to be organized, but lazy. Look up. I'm going to cross out the squared and just put a big square root around the other side. If you do that, I'll figure out, Danica, what you were getting at. So VF is going to be big square root of, VI is 12.5, don't forget the squared, plus 2 times 9.8 times 126. Now, how do you type this into your calculator? Those of you with the fancy schmancy fraction buttons, probably when you hit square root, it does a little indent and continues the square root line, and you can do that. Typically what I do is I type what's inside the square root first. I'm going to go 12.5 squared plus 2 times 9.8 times 126. I hit equals, and then I go square root answer button. And this is also now the time for you to say, if you don't know where your square root or your answer button is, now is the time to ask, and I'll help you with that. So if you can't find your square root or your answer button, let me know. Yeah, you're going to get 51.2 for that, I think. Did I make a typo? That's right, yeah? 51.2430483. Okay, let me come help. Is that right? Okay. How many sig figs do I want to go to in my final answer? So 51.2. Units, Mud. Meters per second. Okay. Example 5. Ooh. Sheesh. Zach, which equation? First of all, what are they asking me to find? What's got a question mark next? Yep. Which equation? And all of you play along on the home game as well, right? So try and figure out which equation we're talking about here. Oh, I think I know. Think you got it, Zach? Read it. You're right.
Yeah.
I did. VF what? Thank you. Yeah. By the way, can you see what one of the common mistakes kids, they forget the squares as they're writing it out? Don't be that. I gave you a challenging one because you looked like you needed it. So let's keep going. What are they asking me to find? There it is, right there. What side is it on? The right. What side's going to drop down like a domino then, Zach? Oh, okay, sorry. My mistake for assuming that you were faster than you are. I'll never make that mistake again. Oh, that came out. Yeah. Good. By the way, can you see that with practice, you could probably track a lot of this in your head? That's what we're going to get to. What's right next to the A? Hint, there's two things. There's two things. What are the D and the 2 doing to the A? So? Remember that, remember that, remember that. What else is on the same side as the A? What's the VI squared doing? So? What order? Reverse BADMAS. Talk me through it. VF squared, keep going. Talk me through it. Yes. Yes. And if you don't mind, I'm going to put the A equals over here. Yes, that's another equation. Are we going to memorize it? No! We'll learn to derive it. I mean, if Zach can... Never mind, that came out wrong. Sorry. Zach, what was V final? Yep. So we'll put a 12 in. By the way, the other thing I've done for each of these is I've scanned the units for yuckiness. No kilometers, no hours, nothing wonky. 12 squared minus VI, 20, yes? Squared all over 2 times 86. Zach, is this a fraction? Is there more than one thing on the top? I'll have to put brackets around the top. Is there more than one thing on the bottom? Yes. This time, unless I have the fancy fraction button, I'm going to have more than one thing on the bottom. And you get a little bit of a weird answer, or do you? What's a little bit weird about your answer? Is it negative? Wait. Zach, what was VI? VI? What was VF? Did we speed up or slow down? Are we expecting a positive acceleration or a negative acceleration? I was expecting a negative answer. The fact that my calculator gave me a negative answer didn't freak me out. It relaxed me because it said, I probably did this right. I don't think I could have fluked into that. So it's going to be 12 squared minus 20 squared, close off the top, divided by 2 times 86. Did you all get negative 1.49, I guess, if I go to 3 sig figs? Units, Zach, it's an acceleration. So as we like to say, meters per second squared. But I would have lived with meters per second. But I also said, wow, you're writing extra work when you don't need to. First time I've ever seen a teenager do more than necessary. Anyways, that came out wrong. You see what we're trying to get to? Yeah. Good. Taryn, let's bring on the challenge. I like example 6, I like example 6, I like example 6. Example 6 is a nice question. Why would I say that? Did you hear me say that or you just noticed? Okay. Taryn, which equation? Can you read it? What are we trying to get by itself? Why can't I? Yep, loud and proud. What? Are you grade 12 or grade 11? Oh, so this is the quadratic situation. Grade 11s, you're going to learn how to solve an equation where you have two variables. There'll be x's in grade 11, but an x squared and an x, and you can't get the x by itself because there's two of them. You'll learn this year how to do that. For now, I have to assume you don't know how to do that. So why did I ask this? I contrived this. Look at the data, Taryn, that I gave you. One of those values is a 0. Which one? The VI. This number right here is a 0. In your head, Taryn, what's 0 times 5? What's 0 times 10? What's 0 times x? What's 0 times t? This whole term vanishes. So I can ask you to solve this equation for t, but only if one of the values is a 0, and you go from 2 t's to 1. Now I get a special subcase, yet another equation. Are we going to memorize it? No. It looks like this. D equals AT squared over 2. No, Mr. Duick, it was a half AT squared. Yes, okay, fine. I could put the 1 in front of the A. Can you see the 1/2? Okay, I'm not going to bother. I also know that some of you hate fractions. That's the math F word as far as you're concerned, not the F word you're thinking of. And so some of you might prefer to write this as D equals 0.5 AT squared. It's the same equation. I'm fine with that. Karen, which one do you like better, the one on the left or the one on the right? Taryn, which one do you like better, the one on the left or the one on the right? Very good, Taryn. I'm so glad you picked up on that. I'll take both, but I'm going to do the one on the left first. What are we trying to get by itself? See it? What's right next to the T? How will I move the A over? Yep. How will I move this 2 over? And I'll end up with this. 2 times D over A equals T squared. You did like the one on the right. Fine. What's the 0.5 and the A doing to the T? So how I move them over. Or I'll get D equals 0.5A equals T squared. Those two equations mean the same thing. Timesing by 2 and dividing by a half, you end up with the same result. Except I have a T squared. So you can either use that version. I don't care. I just like this one because it's bad math manners to have a decimal inside of a fraction. It's not wrong. Just like it's not wrong to walk around with something hanging from your nose, but probably society will get you to change that. In math, a mathematician would say, really? No, that looks prettier to us. So whichever version that you want to use, I'm going to do the left-hand one. You can choose. I'm going to plug in our numbers. You can plug in your numbers as well. So T is going to be the square root of 2 times 2400 divided by 20. Or 2400 divided by 0.5 times 20. I don't care. I usually end up typing what's inside the square root first, divided by 20, and then I go square root answer button. Whoop, typo. Answer button. I can do some of this in my head. It's going to be 15 point something, yes? Yeah, subtract 15.4-ish, 5, 6-ish? 15.5? Yeah? Taryn, units. What did we just find? I'm going to say to you, that's a bad guess because I saw what you did. You didn't ask, what did we find? You just blurted out some units. No. What did we find? Time. Seconds. Has to be. Come on, you don't want to go work for Verizon. You can do so much better. Nick, you made it? I threw a lot at you. That's the gist of what we're doing, except folks, I couldn't look at every conceivable possibility. There are some questions in the homework where, oh, we didn't rewrite that equation yet, or oh, we never got that by itself. I did that on purpose, Ashley. I want to see if you can figure it out yourself. If you can come to a question and, what the, aha! And then have that inspiration. You're awake now? Good. Have that inspiration yourself. So there will be questions deliberately today in the homework. I haven't covered everything. Your homework is, though, every question, try every single one. You can probably do it right on the page if you write medium small, or you can do it on a separate piece of paper, except, what did I say at the beginning of class? First of all, pause, because that's what makes sense to people on YouTube.